Hey everybody, in this example we are going to graph the given polynomial. Now fortunately for us, beautiful, this polynomial is already factored. It can't get any nicer. And we all know I have my doofy little line of funky zebras, enjoy pink, marshmallow, goblins. So let's use these silly letters to help us along. Graphing polynomials, factor fully first, and done. Zeros with the zero product property. That's up. Okay. So this is really y. And when you set y equal to 0, you're solving for x-intercepts. All x-intercepts are a number, comma, 0. So we call them zeros, like nickname. That's their last name is 0. Got it? So -2 equal to 0 is just silly and ridiculous. It's not an x-intercept. That's just a false statement, a throwaway. X plus 4. X plus 4 equals 0. That means x equals -4. Next, x minus 1. We just deal with the inside. We've already discussed why we don't have to worry about that multiplicity at the moment, or exponent on the outside. X equals 1. And then x plus 1 is 0. X equals -1. Okay, here we go. Now, those are the zeros. If you wanted to write them as intercepts, we could write them as ordered pairs. That's beautiful as always. And behavior. Let's check that out. Well, we need the leading term, which is -2. I don't feel like expanding, at least not right now. So it's -2, x to the second will be my biggest power, x to the fifth, x, so that's going to be x to the 8th. So what's your end behavior? Well, down and down, of course. Negative tells us the right side is down. Even power tells you the left side is the same as the right. Beautiful. So that's our end behavior. Pink is plot. Plot all these points. Okay, don't mind if I do. So 1, 2, 3, 4. 1, 2, 3, -4. So 1, -1. And -4. And behavior, I know these sides are both going to be pointing down. So we got started. Next thing up, marshmallow, multiplicities. Well, what's the multiplicity of each factor? So I wrote these down in order of the factors. The multiplicity here is 2. That means it will behave like a quadratic at -4. That means it's either going to look like this at -4 or it's going to look like that at -4. We'll figure that out. So I'm going to put a little Q for quadratic by the -4. 1, 0, well, that came from here. Now, fifth power, we've had this conversation. We're going to use the word cubic. I'm going to put a little air quotes. It's really quintic, but the general shape, it's going to more or less look like a cubing function. The cubic, in the event that it's like a comparison, a cubic, say, looks like this, where it passes through, say, 0, 0, 1, 1, and -1, -1. What happens as the odd numbers increase is this part gets a little flatter, and then after the 1, 1, the part gets a little steeper. So this is a little bit more squared off, and then this is a little bit more steep. But we're not going to worry about that detail at this time. All we're going to worry about is that little squiggle of a shape. So at +1, 0, it's going to look either like that or like that. And then this one came from there, which is a 1 power. So it's more or less linear. So that means it's going to look like that or like that. So that's here. So L for linear and C for cubic. Again, I know it's quintic, but I don't want to put another Q, and cubic is good enough. Next, this arrow is down here. So this quadratic has to have a bit of that shape. We're on bottom, we're on bottom. The linear is going to look kind of like that. We're on top, we're on top. The cubic, it's going to look something like that. Now, smooth it all out, connect our puzzle pieces, and there you go. Smooth and continuous, best as we can. Is this totally perfect into scale? Well, no, we don't know all the heights and all that right now. We will learn more about that in, say, calculus, but try to make it as smooth and curvy and lovely as we can. And that right there is the graph. Sorry, it gets so blurry. That is the graph of this polynomial function. If you wanted a little bit more detail, you could also find the Y-intercept. We fill in 0. We'll get 0 plus 1 is 1. Negative 1 to the 5th is negative 1. 0 plus 4, 4. Square root is 16. Negative 32, negative 1. That should be a positive 32 up there, the Y-intercept. So that's why I never put tick marks on my y-axis. The numbers are usually quite big. So over here, that's going to be 32. We want to write down our y-intercept. We could write it as an ordered pair, 0, 32. Not to be confused with our x-intercepts, which would be something like 1, 0. Negative 1, 0, and the negative got cut off, but negative 4, 0, something along those lines. All right. So I hope this was helpful. I hope you did a good job. That right there was our factored form. We will hopefully do the standard form in a different video. I just want to get to the nitty gritty right now. The next example will probably pop up in a box on the screen. And good luck with your math.